We're now going to review sigma notation and also some summation formulas. So if we look at the sigma notation here, basically this is your Greek letter sigma. And what this really means is we want to look at summing up from starting at our lower limit I equals 1 to some upper limit n. And this is just representing a sub I, representing your term. And basically what this means is you would start with I equals 1 and plug 1 in for the I, so you would have a sub 1, and then you would add, then you would count and plug in a 2, and you get a sub 2, and you would keep doing this all the way up until you get to this upper limit. So if this upper limit was n was 3, then you would have a sub 1 plus a sub 2 plus a sub 3, and you would sum those up together, and that's your answer. But here, this is going to whatever the upper limit is, so this would be a sub n. Okay, the letter I is simply the index of summation, and a sub I is the ith term. So a sub 1 is the first, a sub 2 is the second, and we're simply going to add all of these together up to what we call the nth term. Now, most of the time you'll see the letter I here used as the index of summation. Sometimes you'll see J or K, but this is just a variable that's used here to indicate your ith term. So, for example, below here we have I equals 1 to n, and we just have a constant 5. So what this would mean is, if you notice, there's no I here, so all that this means is if you plug 1 in for I, our number still remains 5. And then you would plug in another number, and it remains 5. And this keeps on going till the nth term. Well, let's say that, for example, n is equal to 10. So that means we would keep doing this 10 times. Well, what does that mean? Well, that means we're going to add this number up 10 times. So that means 5 plus 5 plus 5 plus 5 plus 5. And we're going to do that 10 times. Now, you probably can figure this out. If we're going to do this 10 times, what does that mean? Well, we're going to take the total number of times here, which is 10, and we know that we can represent repeated addition with multiplication. So we're going to take our number 5 and simply multiply that by 10. So we know the sum is equal to 50. So the summation here is just a way of summing up some values, in this case from I equals 1 to 10. And below here you will see our summation formulas, and the first one says if you have I equals 1 to n, where c is a constant, then this summation is simply going to be equal to c times n. Well, our constant up here above, our c value, happened to be the 5, and the nth term is the upper limit, and the nth term for us happened to be the 10. So we'd simply multiply 5 times 10. That's what this first summation formula is telling us. And then we have another summation. Number 2 says that if you have I equals 1 to n and you're summing up this with I, then that just means you would have plug 1 in for I and you'd get 1, then you'd plug in 2, so you get 1 plus 2, and you keep going. So you get 1 plus 2 plus 3 plus 4 plus 5, all the way up to this nth term. Well, this is the formula for that. This says if we know the upper limit, this nth term, then the summation here is just going to be the upper limit n multiplied by the upper limit n plus 1, all divided by 2. And then you can see a similar formula for number 3 for I squared and then for I cubed. So we're going to look at an example of how we can use these formulas. For example, if we look at the sum of I equals 1 to 15, and our term here is 2 times I minus 3. So if we were to do this by hand, what this really means is we would take and plug a 1 in, and we would take and multiply 2 times, we would take 2 times 1 minus 3 plus, and then we would go 2 times 2 minus 3 plus 2 times 3 minus 3, and we would have to continue all the way up until we got to 15, until we had 2 times 15 minus 3. So clearly this would be very time consuming to calculate by hand, so we can use these formulas here above. And to do that, we know that we have the sum of 2i. Well, we have the I that is represented by this formula here in number 2. The I is n times n plus 1 over 2. So if we take this part, we can say this is going to be equal to 2 times I, but in place of I, we can plug in n times n plus 1 over 2. Okay, then we have minus 3, our constant term, but we know the constant term here is going to be multiplied by, this is using number 1, our constant term is multiplied by n. So that's minus 3 times n. Well, of course, what is our n value? Our n value is the upper limit, which is 15. So we can simply plug 15 in for n, and we have 2 times 15 times 15 plus 1 over 2 minus 3 times 15. And if you go through all the numbers here, you're going to end up with an answer of 195. So that's a lot easier than going through this whole step one at a time. So that's the advantage of these summation formulas. Now, I do want to look at an example of how we can take this same problem where we have the sum of I equals 1 to 15, 2i minus 3, and I want to look at how we can use the calculator to solve this particular problem for us. So if we use the calculator, and depending on the type of calculator you have, or the TI-83 or TI-84, there's a couple ways that we can do this. And for this example, the easiest way is if you have a TI-84 Plus, you may end up with something of this type. If you go to Math, and then if you scroll all the way down under Math, you'll see, I think it's at 0, you should see summation, and if you select that, you will simply see your sigma notation here, and you could type in the expression just the way you see it written on the page. So for our example, here we have two I minus 3, so we could certainly, now instead of I, I'm just going to use the variable x on your calculator here, so we can certainly use that. So I'm going to have x equals 1, and then hit the cursor over, and the top limit is 15. Hit the cursor over, then we can type in the expression, and again, because I used x equals 1, I'm just going to simply type in 2x minus 3, and then we simply hit enter, and we get the same answer of 195. Now, if you have another calculator that's TI-83 and it doesn't look like this, or you don't have this form, another option is to go into second stat button. So hit second function stat, scroll to the top to math, and then number 5, which is sum. Okay, so then on the screen you're going to see sum with parentheses. Okay, then you're going to hit second function stat, scroll over to ops, and this time you're going to hit number 5 again, but this is sequence. Now again, on your calculator it may look like this, and it says type in your expression, That means you would type in 2x minus 3. So 2x minus 3. And the variable is simply the variable you're using, which is x. Where do you want to start? We start at 1 and we end at 15. And of course here the step, we're counting by 1, so your step is 1. And then if you select paste, it's going to paste it into your calculator. Now what's happened here, if you don't get that previous screen here, then once you select sum sequence, if you see this on your calculator and all you have is sum and then sequence like this, then all you have to do is type in the expression 2x minus 3, and then you want to put a comma, and your comma is located right above your number 7 key. Okay, and what this is going to look like, (2x minus 3, comma x). So you type in your variable, and that's the, here in the function here it's I, but we're using x. And then you would type comma, and then you're going to type in your lower limit, which is 1, comma, upper limit, which is 15, and then you're going to close your parentheses for the sequent and close the parentheses for the sum, and at that point you can hit enter, and this would be equal to 195. So if you don't get the nice little sigma notation, if you just get sum sequence, you simply type in the expression, comma, variable, comma, lower limit, comma, upper limit, and make sure you close the parentheses. Okay, so this will work very well as long as you have your lower limit and an upper limit. All right, now if you notice our next example, here we don't have an upper limit. It just simply says we're going from I equals 1 to n of I squared over n cubed. So in this problem, we're going to have to use the summation. And what we want to do here is we want to rewrite the problem so that we don't have this summation. And you notice above here in this step right here, from the sigma notation down to here, notice we drop out the sigma notation, which means the sum, because the formula here in green and then in purple, that formula is actually doing the summation for you. So that's why we drop out this sigma. And we want to do the same thing with this following example. How do we get rid of this sigma by using those formulas? Well, if we look above, we have an I squared. So do we have an I squared? Well, the formula up here for the I squared is n times n plus 1 times 2n plus 1 all over 6. So we're going to use that as a substitution for the I squared. So in place of I squared, now if you notice on the bottom we have n cubed. To make things a little bit easier, I'm going to take this n cubed and write it as 1 over n cubed, because remember, once we know the value of n, that's just going to be a constant number. So all we have to do is substitute in for the I squared, which we said would be the n plus 1 times 2n plus 1, all divided by 6. So once we substitute that in, notice now with our equal sign, once again we drop out this summation symbol, the sigma, that disappears. So now from here, how can we simplify this expression? Well, probably the easiest thing to realize is we have an n on top, because everything's multiplied on top, everything's multiplied on the bottom. This n on top will cancel out one of the cubes on the bottom, so this will become n squared. And then if we FOIL the top, we're going to end up with 2n squared plus 1n plus 2n, which becomes 3n, and then 1 times 1 is 1. And this is all over the 6, but we still have the n squared, so this is all over 6n squared. So this would be rewriting the sigma notation in this particular formula. So if you had I squared over n cubed, and if you know the value of n, you could simply plug that upper limit n into this formula, and that's going to give you this particular sum. Now, what if we're posed with the question and we want to know what happens as this upper limit n goes to infinity? Well, that means we could certainly take the limit as the upper limit n goes to infinity, and our formula says we have 2n squared plus 3n plus 1 all over 6n squared. So how do we take the limit of this expression? Well, hopefully you remember we could simply compare the largest exponent on top, which is a 2, with the largest exponent on the bottom, which is a 2, and then because they are the same, remember the limit is simply going to be the coefficient of each one, the ratio of the coefficients, so that would be 2 over 6, which would reduce to 1 over 3. So if we wanted to know the limit as n goes to infinity, so as this upper limit n went to infinity, then this sum would equal 1/3. Now I wanted to go ahead and show you this last little step here with taking the limit of n going to infinity, because this is a property that we will apply here in the next couple of videos, so how we can find the area of some particular problems. So this is something we'll refer to a little bit later. So at this point, I just want you to get comfortable with finding the sum using the formulas here above, and also using your calculator. And once we have the lower and upper limit, it's certainly fine to use your calculator. You may want to practice a couple examples of using the formulas, because like I said later on, when we do not have an upper limit here and we just want to come up with a formula, you're going to have to use the formulas to replace n. And especially when we look at taking the limit as n goes to infinity.